Let's finish up our Calc 2 review with Part 8. We're going to talk about vectors a little bit. Let's choose problem number 59 from a study sheet. We've got this. We've got u vector is equal to 6i plus 1j. We've got a v vector is equal to 1i plus 1j. And we've got a w vector that is 1i minus 1j. The question says to find scalars a and b so that a multiplied by vector v plus b multiplied by vector w gives us vector u. So this goes by component. What we get is this a times this I value, b times this I value equals 6. So we're going to end up having this equation. 6 is equal to a times 1 plus b times 1. So a plus b equals 6. Now the j's also work that way. So 1 from the u vector is equal to a minus b. So a minus b. Now, this is kind of nice because we can add the two equations together and get 7 equals 2a, drops the b out, so a equals 7 halves. If a equals 7 halves, then we can put it in either one of these and figure out what b is. So if we've got 6 is equal to 7 halves plus b, then subtract 7 halves from both sides. We've got 12 halves for 6 minus 7 halves is equal to 5 halves is equal to b. So there's a b value. So we can check that out. Let's take u, so that's 6i plus j plus 1j, and see if it is equal to a, 7 halves, times 1i plus 1j plus 5 halves times 1i minus 1j. Well, 6i plus 1j is equal to 7 halves I plus 7 halves j plus 5 halves I minus 5 halves j. Let's put the i's and j's together. 7 halves plus 5 halves, that's 12 halves, so that's 6i. 7 halves minus 5 halves is 2 halves, that is 1j. So there you go. All right, so that's one thing you can do with vectors. Some other problems, let's take something else here. Here's a vector that is number 62, right? It says u equals, this is in component form, so this type of notation, minus 3, 6. So that's minus 3i and 6j. And then it's got the value v, a vector v. So v is equal to minus 8 minus 4. And the question says to find u plus v. Find u plus v. Now, hopefully this is easy. You just go part by part. So minus 3 plus a minus 8, you get minus 11. 6 plus a minus 4 gives you 2. So, and yeah, that really is as easy as it seems, okay? So, let's write a vector. This one's from 63. It says to find a vector AB. So we've got to find a vector AB. We have A as a point, so A is a point and it's in 3 space, so that's kind of different for us. But minus 9, minus 5, minus 1, and B is a point, minus 4, minus 12, 2. So let's just write the vector AB. Now, what this indicates is that we start at A and end at B. So you start with the end and go backwards. So minus 4 minus minus 9. So minus 4 minus minus 9 is the first part of our vector. The x's, or the i's in vector format. Minus 12 minus minus 5. Okay, and then 2 minus minus 1. So what do we have? We've got minus 4 plus 9 is 5. We've got minus 12 plus 5 minus 7, and 2 plus 1 is 3. So there's our vector made from 2 points. Okay, another question, something we do with vectors. This is called a dot product. So I've got a vector v that is 6i plus 5 minus 5j. So it's equal to 6i minus 5j, and then minus 4i minus 2j. So u is minus 4i minus 2j. The dot product, v dotted with u, does not give a vector, it gives a constant. So it is 6 times negative 4 plus minus 5 times negative 2. And you get a constant, and given a constant, you can't go back to the vectors. It doesn't go backwards in a very identical way to get what we need. So anyway, 6 times minus 4, minus 24, and 5, that was supposed to be multiplied, wasn't it? Times 2 is 10, so plus 10 is equal to minus 14. Now the most important thing I think you need to know about dot products is that when you find them, if you get something other than 0, what you know is that these two vectors are not at 90 degrees with each other. Now that's probably the main thing with dot products. You use them a lot, but that's the main thing to think about. So this is minus 14. They are not at right angles with each other. So that's kind of an interesting act. Okay, so let's find the angle between two vectors, and I'm going to use a different one here. So the angle between, okay, so the angle between is that u dot v, so u dot v over the length of u, length of v, those are called magnitudes, is equal to the cosine of the angle between them. Okay, so there we go. Now what is my u and what is my v here? I've got a vector u that's minus 2j, so u equals minus 2j. So it's just going up the y-axis there. And v is equal to 9i minus 7k. 9i minus 7k. All right? So this one's kind of fun, but anyway, take the dot product. We've got to take the dot product. So the I times the I, so u dotted with v, so the I times the I is 0, plus the j times the j is 0, plus the k times the k is 0, so it's 0. Cosine is 0 at 90 degrees, so theta is 90 degrees. Okay, now let's practice the magnitude just so you know how to do that again. This one, pretty easy, square root of minus 2 squared. So magnitude is 2, okay, magnitude. Magnitude, I didn't need to dot that. Okay, the magnitude of v is equal to the square root of 9 squared plus minus 7 squared. So it's like a distance formula, basically. We've got square root of 81 plus 49, okay? So that is square root of, what, 130, I guess, okay? So that's the magnitude of v. And we didn't have to deal with that because 0 over stuff is also 0. But anyway, that's kind of an important thing. One thing about vectors is if they meet at 90 degrees, they are called orthogonal. Okay, so orthogonal. Well, I am going to say that we've pretty well been through a bunch of practice problems. Not all 66 here. I haven't done all of them, but hopefully that gives you a little bit of an idea about the course, Calc 2, comprehensive review. So anyway, enjoy studying.